So I'm Dr. Lutz Mary, Associate Professor in the Department of Computer Science and Engineering. I'm going to take the topic implementation levels of virtualization for the subject cloud computing. So implementation levels of virtualization. First of all, you have to know the term virtualization. Virtualization is a computer architecture technology by which the multiple virtual machines are multiplexed in the same hardware machine. So why I have to use a virtual machine? The purpose of the virtual machine is to enhance resource sharing by many users to improve the computer performance in terms of resource utilization and application flexibility. The idea is to separate the hardware from the software to yield a better system efficiency. A traditional computer that runs with host operating system is for that particular hardware architecture alone. After virtualization, different user applications managed by their own OS, that is guest OS, can run on the same virtual machine, same hardware, independent of the host OS. The host OS will be different, the guest OS will be different. This is often done by adding additional software called virtualization layer shown in the diagram. So the traditional computer is having a hardware, host operating system and application, whereas after virtualization, the hardware running the host OS, the hardware will be the same. You can have the virtualization layer, that is a hypervisor or virtualization machine monitor, can have the application as well as the guest OS along with the hardware. So virtualization can be implemented at various level: instruction set architecture level ISA, hardware level operating system level, library support level, application level. We will see one by one how it is ISA level will be carried over. Virtualization is given by ISA host machine. So you have to do the emulation. The emulation method is using code interpretation. The interpreter program interprets the source instruction to target instruction one by one. So process is relatively slow. So for better performance, dynamic binary translation is desired. This approach translates basic blocks of dynamic source instruction to target instruction. The basic blocks can also be extended to program traces or super blocks to increase translation efficiency. A virtual ISA requires adding a processor specific software translation layer to the compiler. So next one is operating system level. OS level virtualization create isolated containers on a single physical server, and the instances, OS instances, to utilize the hardware and software in data centers. The container behave like real servers. So OS level virtualization is commonly used in creating virtual hosting environment to allocate hardware resources among a large number of mutually distrusting users. Hardware abstraction level, it is performed on the right of the bare hardware. So on the other hand, there is a process manages the underlying hardware through virtualization. So what's the basic idea? To virtualize computer resources. So what are the resources? Processor, memory and IO devices, source hardware utilization rate by multiple users that will be concurrently upgraded. Operating system level virtualization create isolated containers. So library support level virtualization with library interfaces is possible, controlling the communication link between application and the rest of the system through API hooks. The software tools, that is Wine, has implemented this approach to support virtual Windows application on top of Unix host. Another example is vCUDA, which allows application executing the within the virtual machine to leverage GPU, graphical processor user interface, hardware acceleration. User application level, the application runs as a process. The application level the virtualization is also known as process level virtualization. The most popular approach is high level language VMs. In this, the virtualization layer exports an abstraction of virtual machine that can run programs written and compiled to a particular abstract definition. Any program written in HLL can be compiled for this VM. You can also run on that. So the Microsoft .NET, CLR, JVM, Java virtual machine are the good examples. So process involved wrapping the application in a layer is isolated from the host OS and other application. So the resulting application is easier to distribute and remove from user workstation. So next one is it is slow to initialize the hardware. So the VM, because the VM creates its own image from the scrap and storage of such images are slow. So it inserts a virtualization layer inside the operating system to partition machines. Then we can have host-based virtualization. Host computer, you can have the hypervisor or virtual machine monitor. Ring 1, the binary 0 will do the binary translation of the OS request by using hypercalls. Direct execution of the user request will be done on ring 3. So next is application. This is para virtualization application. So para virtualized guest OS, hypervisor, monitor. Something continuous. Para virtualization need to modify the guest OS. So it provides a special APIs requiring substantial OS modification, the performance degradation. So it's one of the critical issue. So the guest OS or para virtualized, they are assisted by an intelligent computer to replace non-virtualized OS instruction by hypercalls. The traditional x86 offers 4 instruction ring 0, 1, 2, 3. The lower the higher the security. Direct to IO virtualization, it lets VM devices directly. Another way it can achieve close to native performance. Another way to help virtualization is set virtualized IO, SVIO. So all the tasks associated with virtualizing an IO are encapsulated in the SVIO. Thank you.